So I'm going to talk about integration by substitution. And let's begin by considering the following integral. So we see that there are no basic rules of integration that allow to find this integral, therefore we're stuck. And I'm now going to present a technique that does allow to evaluate this integral. Let's begin by recalling the chain rule from differential calculus. So the derivative of the composite function f of g of x is equal to the following. So the derivative of the outside function f prime evaluated at the inside function g of x times the derivative of the inside function g prime of x. Now knowing about integrals, we can say the following. So whenever I see an integrand of this form, so I've got a composite function and next to it the derivative of the inside function, well then I can say this integral is equal to what we have here on the right side. And there's a technique for evaluating integrals of this form, which is called integration by substitution, and I'm going to present that now. So we begin by making the following substitution. So u is equal to g of x being the inside function here. And now we find the differential of u. And now I isolate d of x on the right hand side of the equation. And now I make this substitution here on the left hand side of my equation. And what I'm left with is the integral of f prime of u du, and this here is simply equal to f of u plus a constant. So I've been able to evaluate the integral that we had earlier. So let's now understand this technique a bit better through an example. So let's look at an example now. So the first step is recognizing that what I've got here is a composite function. Okay, so the inside function is x squared plus 1, and the outside function is the power function to the power of 1 over 3. And next to this is 2x, and 2x is the derivative of our inside function. Therefore, we can use integration by substitution. And the first step is the following. So we see that u is equal to x squared plus 1, and now we find the differential of u. And now we isolate dx on the right side of the equation. And now we substitute u inside of our integral, therefore we get the following. And the 2x cancels out. So now we're left with an integral that we can find using the basic rules of integration. Therefore, what we get is u to the power of 1 over 3 plus 1 over 1 over 3 plus 1 plus a constant. And this simplifies to the following. And this is divided by 4 over 3, which is the same as multiplying by 3 over 4. And we add a constant. So now we simply replace u with x squared plus 1, therefore we get the following. And let's now consider our initial integral, which was the following. So we firstly notice that we've got an inside function here, and next to it the derivative of the inside function, which is 2x. Therefore we can use integration by substitution. So we begin with the following substitution. We find the differential, we isolate dx on the right hand side of the equation, and now we rewrite our integral, and now the 2x cancels out. We rewrite square root u as u to the power of 1 over 2. And this integral using the basic rules of integration is equal to the following. And now we replace u with x squared plus 1. So now we have our integral. And this concludes the presentation on integration by substitution.